So now,
Okay, see, some the not that much good notes is there, but okay. But to understand this one in the basic way, it is quite okay. So the first definition already you told, that is the elements in which last electron enters into s orbital is known as s block element. That is very simple, right? Where they are located in periodic
yes,
table, where these elements are located in periodic table. So s block
so
elements
group
are
one and group.
group 1 and group 2, that is extreme left side of the periodic table. In two group, that is group 1 alkali metal and group 2 alkaline earth metal. So these portion you know very well. Okay. Now, if you talk about the group 1 elements, okay, group 1 elements are also known as alkali metals, as their hydroxide are extremely alkaline in basic, in water. No, alkaline in water. So hydroxide, that is one thing is also there. So if you are talking
Their
about,
oxide is reacting with water to form their hydroxide, which is basic in nature.
and hydroxide, if you are dissolving in the water, if you are dissolving in water, so it will give, that is Na plus and OH minus ion. And this is also what is going to
Yes.
be, this is explaining, that is, this is the basic, right? For example, here you see the what are the oxides are there, LiOH, NaOH, KOH, RbOH, CSOH. These hydroxide are alkaline in nature, so they are known as alkali metal. So this definition is also acceptable. And if you see this one, if you see the NCRT, NCRT also saying the similar line, that why they call the alkali metal. But in NCRT, we need to read the line by line. I think we discussed some of the portion. We
No,
discussed.
no, sir, we are not. Otherwise, I would have known. Sir.
Hmm. They are saying they are collectively known as alkali metal, right? These are
Yeah.
so called because they are hydroxide on reaction with water, which are strongly alkaline in nature. So that is same line are there. Can you see? Can you read this one?
Yes,
Yes.
yes,
Okay.
yes.
Half-life period I already told you. Francium is the highly radioactive. Okay. Its longest life isotopes has half-life of the 21 minutes. How many minutes are there? These are database questions are important. Okay. Here the another is there that the beryllium is rare, and radium is the rarest of all, comprising only how much is there, 10 power minus 10% in igneous rocks. So these things,
Yes, sir.
okay, now come back here, the slides only we are going. This one, there is gone. One second. Oh, okay, let me find out. Here the group 1 element, that is what we know, that is Lina ne ki rab se faryad. So for this element, you know, lithium, sodium, potassium, rubidium, cesium, francium. Lina ne ki rab se faryad. How we get? By adding the plus 8 here. Then again you add the plus 8. This is magic number. I already told you in periodic table. Plus 18. Then again plus 18. And finally plus 32. So you are going to get. If you
So
know
this
the
is the big number. Na?
what number?
Sir, these are called magic numbers. This one only.
Yeah, this number called magic number. Suppose if you are including the hydrogen, then lithium, sodium, potassium, rubidium, cesium, and francium. These are elements. So first period element, how many elements are there? First period, 2 elements. So we add the plus 2. Second period element are how many are there? 8 elements. So we add 8. Third period again 8 elements. So we added 8. Then next period, that is 18 elements. Okay. Fourth period, fifth period, 18 elements. So 18, 18. Sixth period and seventh period, how many are there? 32. So these number are called magic number. So hydrogen we are not taking, we're only taking lithium. So lithium, sodium, potassium, rubidium, cesium, francium. Is it okay?
Yes.
Hmm. Why we are adding 8? You must be knowing, because in the second period 8 elements are there. Third period 8 elements are there. So that is that many elements
Sir,
we add.
that is 12 to the atomic number.
Yeah, correct. Here you see electronic configuration that you know. These elements are valence cell
Yes.
electronic configuration NS1. that is only one valence electron. So here is 2s1, 3s1, 4s1, these are. Now the question is there, how they ask the question. Alkali metal are, alkali metals are paramagnetic. They are the paramagnetic. Question is paramagnetic. But their salt are diamagnetic. Why? Their salt are diamagnetic. This is what the question. What will be the answer, Sanoy?
Sir, paramagnetic because they be group one. Group one, group electronic one electron in the state.
Okay. So they are having the one free
There,
electron. They are having the one free
during
electron.
short conductivity,
Yeah, correct. They are having free electrons, so the alkali metals are paramagnetic. When they are forming the salt, NaCl, so this electron gone one electron here, so it is forming Na plus and Cl minus. Okay, so Na plus, if you see the
yes,
configuration, so what is there? 3s2 and 3p, because you see its valence
sir,
configuration.
NaCl, sir, then the one electron this
Na plus if I write now, so
sir,
what
Na
will be there?
plus 2 to
1s2,
2
2p6. So there is all paired electron. You can find all paired electron. If all paired electrons are there, there will be the diamagnet that will be repelled in the magnetic field. Here 17, but one negatives are, so 1s2, 2s2, 2p6, 3s2, 3p6. Now total 18 electron. Here you also find that is all is having what, the paired electron. If there is paired electrons, so there will be, they are the what, diamagnetic. Getting my point?
yes, sir, getting. Sir,
Okay.
sir, that these things are there in that one, sir, chapter 3, chapter 4, chemical bonding. So there we
Yeah.
are told that if we are having one electron valence shell, so then it is paramagnetic, and sir, if that shell is filled, orbital is filled, so then it is diamagnetic.
Okay. Thank you. Very good. Very good. You remind something. Now, occurrence of alkali metals, since they are the reactive metal, these metals are very reactive, so they are found in the combined state. How they are found in combined state? So in the 10th standard also you study, the most of the element are found in the form of combined state. Why? Three types of element we study in the 10th standard. What we study? Highly reactive, moderate reactive, and least reactive. Yes or no?
Yes, sir. So highly reactive, moderately reactive, and less reactive.
So how they are found? How they found this, all the three type of element? Highly reactive in the form of compound. Least reactive in
The
free state.
moderately reactive, some are compound, some are normal, some are pure form, and low reactive are mostly found in pure form.
Mostly in the, pure uncombined state. Okay. So that is what. Here you see occurrence, how they found. If you see lithium, the lithium is found in the sporandrum. Spondum, spondum. Yeah, you write the petalite. These are the name are there. Okay, let me go back in NCRT and check out, because whatever the points are there in the NCRT, they all are the important one. Okay, anything there they are NCRT one, that is, they all points are important. So in the NCRT it is not there. The occurrence are not there. Obviously, it is occurrence are not there. Alkaline earth metal. In NCRT occurrence are not there, Sanay. So occurrence point of view, you can leave it, or if you can memorize also. So what you will find, see the point are there. Petalite is there. Petalite. This is the formula of petalite. LiAl Si4O10. Okay. And here is this one is spondimine. This is LiAl SiO3 whole twice. Other things are there. Here lithium is quite See this one, nothing we can do until or unless we can memorize. While solving the problem, we will get to know whether they are important or not. Getting my point? When you
Okay,
solve
sir.
the NEET problem now, that time you will get to know these occurrences are important or not. Here, if you see sodium found in the rock salt. NaCl, it is itself is known as the rock salt, right? So this is the rock
Yes.
salt. Cryolite is also important. Why? NaAlSi3O8, cryolite.
Okay.
This is the useful. Cryolite is also useful. It reduces the melting point of the alumina. Al2O3 is there, na? Al2O3. It is also in the 10th standard. 10th standard, you must have studied. So what it was doing, Al2O3, it is having the very high melting point, more than 3000. So when you are adding the cryolite, it decreases the melting point. So we can extract that one, aluminum. From the Al2O3 bauxite ore, we extract the aluminum. In that, what ore we use? We use the cryolite. Getting?
Oh, getting.
Okay. Now see the potassium. If you see the potassium one, this is the saltpeter. Here, what is there? Saltpeter. Saltpeter is KNO3. Okay, KNO3 is saltpeter. Rest of no need to. Okay, feldspar is there. KAlSi3O3 feldspar. No, carnellite is also there. KCl, MgCl2, and 6H2O. Carnellite.
Yes.
Slivine is there. KCl. So KCl, you know, these questions I think asked in the NEET exam. Okay, carnellite one. Cardinalite one. Tomorrow, when I will take the class, now I will tell the previous year question, then you will get to know. Carnellite, because it is the mixture of the KCl and MgCl2. This is the important one, carnellite. Okay. Feldspar, this is the KAlSi3O3. Next one, question is there. Why alkali metals are not found in the free state? Any idea about that?
Sir, that you just told now that alkali metals are generally very much reactive, so that they react with anything they find in their surroundings.
Oh,
Oxygen is abundant in the air, and they form the oxides. So that is why not found in the fish.
here you see the element with electronic number 87. With atomic number 87 belongs to which block? S block, P block, D block, F block.
This should be S block.
S block. This belongs to S block. Here you see the configuration is there. 7s1. Last electron is going to be 7s1. So it is the Rn is there. Rn is 86. Okay, Rn is 86. And then last electron is going to be, Rn is the noble gas. So this is the S block.
Sir, noble gas atomic numbers need to be memorized.
For short configuration, it is need to be memorized, like xenon. If you want to write the short configuration, so xenon is 54 and one electron 55. So this one 6s1. And here, here if I was supposed to write, so I must have write the krypton Kr 36 and one electron 5s1. Here we can write this one up to here. This is the argon and 4s1. So this is the simple one. Here, atomic radii. See, left to right, you tell me what happened to the atomic radii, left to right.
So atomic radii left to right increase.
Atomic radii left to right increase means decreases. Left to right decreases. Decreases or increases? Clear it. Left to right increases or decreases?
Sir, left to right, the atomic number is increasing. So, sir, this atomic radius also increase.
No.
So it will decrease. It will decrease. It will decrease.
Because number of cell is constant. Left to right number of cell is constant. And the atom.
So that attraction will become more, and sir, they will be like occupying less space.
So that is the size will be decreased. So left to right. So means they are the present in the extreme left. S block elements are present in the extreme left. Yes or no?
Yes.
So if they are present in the extreme left, so their size will be highest or lowest?
So highest.
So atomic and ionic radii increases on moving down the group as number of cell increases. So down the group, obviously number of cell increasing, so it will increase. Here you see lithium, sodium, potassium, rubidium, cesium. How much is there? 152, 186, 227, 248, 265. It is keep on increasing. Why it is increasing? Because number of cell you will find it is getting increases. So number of cell increasing, so obviously the atomic radii is also going to increase. Yes, yeah, no.
Yes.
But in the period, it will be the highest one. Ionic radii also you will find this is increasing. 76, 102. Acha, you tell me why the ionic radii you can match here. Can you match this one value? Here lithium is 152, but Li plus is 76. What is the reason behind this? Ionic
So
radii is
just 1
smaller.
minute. So ionic radii.
Be
I
concentrated.
don't know this.
You only told when I was teaching periodic table, you only told the answers. See,
So that one because Li is Li is having the less number of that one's orbitals. So sir, it should be less. Ionic radii should be less.
correct. See, the atom you take, atom, anyone you take. Suppose sodium you take, and Na plus you take. Okay. So what will be the configuration? 281. Na plus 2 comma 8.
So,
Right? So here obviously number of cell are how many are there? 3. And here number of cell are 2. So that is there. But here the proton, can you tell me? Atomic number never change. Proton is how much? 11. Electron is 10. And here is proton is 11. Electron is 11. So which one is going to attract? Which one? Which one? Because proton only attracting. So Na plus, see, more the positive, proton is positive charge in the center, more the positive charge and less the electron. So it will pull very strongly now. But here 11 electron, 11 proton, that much is the not that much it will attract.
okay.
I think you are not understanding.
No, I understood. Not like that.
You see, one, this is the car is there, car, right?
Yes.
It is having the load of 11%, 11%. Okay. And another car,
Hmm.
same power car is there, and it is carrying how much? 10%, 10%. So which car runs faster? Which car run faster?
Yes, sir.
Which one? First one or second one?
Second one.
Second one run faster. It will attract the faster. So same the region is there, na? 11 is there, both 11, but here the number of electron are less. So it will attract
Hmm.
faster. It attracting faster,
Clear.
the radii will be shorter. Yes or no?
Yes.
Okay, okay, Tanoy, okay. Now we are moving on the second point here. You see, ionization energy. What will happen? Ionization energy. What is ionization energy? Amount of energy required to remove the electron from isolated gaseous atom. See, on moving down the group, it decreases as number of cell increases and force of attraction between nucleus and outermost electron decreases. And hence, less amount of energy required to remove outermost electron. That is, ionization energy decreases. Now, this portion, I hope you will easily understand that I read fastly.
Sir, can you please scroll the screen a bit up, sir? I was writing down everything, so that part I missed.
What
Just
you
1 minute, I will.
not required to write, Sanoe.
So then it will.
Not required to write this one. Ionization energy, that is the how many group will you write? All the group, down the group, what will happen? Decreases, na? Friend, decreases. All the group. It is decreasing. Why? Why, Sanoe? Number of cell increases, na? Number of cell increases. So force of
Yes.
attraction will
So
increase
then
or
that
decrease.
shielding effect is also increasing.
Shielding effect increasing. So force of attraction decreasing, na? Nucleus and electron. It is decreasing, na? So easily you can remove the electron. So easily you are removing the electron. So more energy required or less energy required?
So less energy required.
Thank you. So lithium, so now how much is there? 520 kilojoule.
520.
Sodium 496. It is decreasing or not?
Yes, sir. Decreasing.
See the if it's continuously decreasing, Sanoy. Getting my point, Sanoy?
Yes, sir. Getting.
Okay, good. If I will go faster, kindly you let me know, na. When
Yes.
there is the Diwali vacation is there, na Diwali. During Diwali, I will
Sir,
teach
I'm
you.
not sure how many days they are giving in our school, sir. I will ask tomorrow in our school, sir, and I will let you know.
That time, but that is 4 days will be there. 3 4 days. 3 4 days I will teach you. Okay. Sunday,
Oh,
Sunday, Sunday, I will connect you more. Means I can teach you 2 times also. So if you are not understanding first time, uh, then again you are having the scope, the things. So don't take too much stress. Getting my point?
yes, sir.
Don't take the stress. Just try to read as much as possible. See here, which of the following best describe the
Describes the
alkali metal?
alkaline.
So see the Acha, I did not write all the options. They are monoatomic form ions of the general formula X minus. Okay. So they were having many options, but they are the monoatomic and they are forming the X minus. Which of the following base describe to alkali metals? Alkali metal. They are atomic form ions. General formula X plus. It cannot be X minus. X plus. Alkali metal like sodium. What is there? That is the 281. Nah. So all the alkali metal what is forming? Na plus and one electron is getting loose. Getting?
Getting.
Okay. Reactivity. Reactivity. Down the group, reactivity increases as ionization enthalpy decreases. So see the many group you will find the reactivity will, what will happen? Down the group increase. Why it is increasing, Sanoy? Increases. In case of metal, reactivity increases down the group. Reason, can you tell me?
Yes. Reactivity increases, sir, because there that same shielding effect is less, means that they are more readily trying to give up the electron, so they will be more reactive.
Correct. See. Wait. So, see here, reactivity of metal. Reactivity of metals. Okay. How easy, how easy electron remove? How easy electron remove? Okay. So, easy to remove electron. How easy to remove electron? More reactive. More reactive. More reactive. Next, if I will talk about the non-metal, non-metal. Okay, non-metal. In case of non-metal, Samay, in case of non-metal, how easy, how easy, how easy it gain electron? How it is it gain electron? Okay, this is more reactive. So the reactivity for metal and non-metal are different. Suppose if I will talk about the here lithium, sodium, potassium, rubidium, cesium, francium. So more reactive will be francium because its I is less. Okay. But if you talk about FCl, Bri, so which will be more reactive? Fluorine is more reactive. When it reacts, it catches the fire. If you talk about oxygen, sulfur, selenium, polonium, which is more reactive? Can you tell
Oxygen.
me? Oxygen more reactive. If you talk about nitrogen, phosphorus, sulfur, no, not
Nitrogen.
nitrogen,
Nah, so nitrogen
selenium,
how it will be?
selenium. So it will be the nitrogen. Okay, let me check out
Sir,
this one.
astatine is the halogen or what, sir?
What?
Sir, astatine is a halogen.
Yeah. Halogen. It is.
But sir, it is synthetic, na, sir? That is not found in nature.
Yeah, synthetic only. Its half-life period is very less, very less. The last, no, whatever the seventh period are there, seventh period, most are the synthetic one, man-made. Seventh period, tracer is
Hmm.
there.
Sir, after 100, atomic number after 100.
Yeah, yeah, yeah. So, did you understand this one, reactivity order?
Yes, sir.
Okay, thank you. Okay, so we finished. Hydration enthalpy. What is the hydration enthalpy, Sanoy?
So when one mole they are dissolving in water, then it is releasing some energy. That one.
Oh, okay, okay. It is the energy released when 1 mole of atoms or ions dissolve in water. Hydration enthalpy, what is happening in the down the group? Since I'm moving down the group, size and ionic size alkali metals increases. So hydration enthalpy down the group
So that will
uh, decreases. What is their rule? Hydration enthalpy decreases. Okay. Now see here, how much increase in case of lithium it releases minus 507, this much energy. But in case of cesium it is very less, minus 276. So hydration enthalpy, if you see, depending on how it is depending, you see, you wrote this point, Sanoy, this point, did you write?
yes, sir. Everything.
So thank you, thank you. So Sanoy, if you talk about hydration enthalpy, okay, hydration enthalpy, there are many factors are there, Sanoy. More the charge, more the charge, more the charge, more hydration enthalpy, more hydration enthalpy, more hydration enthalpy. Right, Sanoy? More
Yes.
the charge, more. If suppose K plus Mg2 plus Al3 plus, so its hydration enthalpy is high. High.
Mm.
Why? This is the first point. Second point. Smaller the size of cation, smaller the size of metal. Size of metal. Okay, metal. More the hydration enthalpy. More the hydration enthalpy. More the hydration enthalpy. Getting some? More the
Yes, sir.
hydration. Okay. So on moving down the group, size decreases, na, increases. Size increases, so hydration enthalpy, obviously it will decrease. Can you understand this?
No, sir.
No.
Yeah, sir. I understand.
See what is
Sir,
happening.
because same thing, sir. That shielding effect only is doing that one.
Yeah,
Doesn't
yeah,
this
yeah.
breaking of bond releases less energy?
See, na, one more point I just see. Bond formation is exothermic or endothermic, Sanjay? Bond formation. Bond formation.
Bond formation is endothermic.
Exothermic. Exothermic. Bond formation is energy release. Bond breaking, if you want to break the bond, energy required. Yes or no? So bond breaking, bond dissociation. Okay. Bond dissociation.
Hmm.
So you need to supply the energy na. Bond dissociation.
Yes.
So what will be there? Endothermic. Endothermic. Yes or no?
Endothermic. Hmm.
But bond formation na. When bond forms, the energy the molecule becomes stable. How the molecule becomes stable? By lowering the energy. No, not getting.
Yes, sir. Hmm.
So
Getting
bond,
it.
oh yeah, yeah, yeah. So if you are saying that bond formation is exothermic, means energy release, yes or no?
Yes.
So energy releasing. So how much? See, the if a smaller size is there, na, more bond will form with the water molecule. More bond, more attraction will be there. In case of a small size, attraction will be more, na. So with the water molecule, more bond will form. If the ionic size is less, a small size, so more bond will form. A strong bond will form with the water molecule. Like this, these are attracting. So more energy will release. Getting?
Yes, sir.
But if we suppose that this one, see, if the size is this size, this big size, which one? Cesium. Cesium is big size. So attraction is less. So it cannot hold the water molecule, na. It cannot attract the water molecule. Can it attract? Because size is too large. Too many cells are there. So if it cannot form the bond, so energy will release less because the bond is forming less. Can you understand anything what I am explaining?
I
Tanmay,
understood.
are you sure you understood?
Yes.
Why in case of lithium, so hydration enthalpy is more, but in case of cesium less hydration
So
enthalpy.
lithium is a smaller atom. So sir, there will be more number of water molecules will be attached to that one. So sir, more number of bond will be formed, and sir, more energy will be released. And sir,
Oh,
cesium is a larger atom. So sir, less number of water molecules will attach because it cannot hold that water. And sir, then less number of bonds are found and less energy is produced.
okay. Thank you so much. So now I think 2 minutes left. Okay, you rejoin, please. Rejoin.
Rejoin.
Uh,